What's up people, and welcome to my tutorial in Pragmatic Data Science. So in the previous video we looked at how you would do matrix multiplication with a vector. And the rationale behind this is that you might have, many rows from your data set that you want to apply the same set of weights to, the thetas here from V2. And now we're going to take a look at a different scenario with matrix multiplication where you have two matrices that you're going to multiply together. And this can be a little bit confusing, but we'll get there in the end. So basically, the reason why you want to do this to start with is that M1 here, you can consider this as still the data rows from the CSV file. These are the values. Each row here corresponds to a row in the CSV file where you would have some set of values. And now what we have in M2 is also a set of weights. So you would have this column is still the same as previously, but maybe you want to test out some other set of parameters for something else that you also want to test on the same data set, but with a different set of values. So basically what you would have is you would also now have many of these. So you would have multiple weights that you want to test out. And the first thing we do is check the dimensions of the matrices. So first off, does these two dimensions match up? And they do. So now, okay, great, we can actually multiply these together. And 2 times 2 is going to be the new dimension for our matrix that we're going to get, which is this one right here. All right, so this works exactly as when you do vector multiplication. So if you don't remember how linear combinations with a vectors are done, basically number 1 of this PDF that is in the repository, go ahead and re-watch that video because otherwise you're going to be super confused at this time. All right, so with that being said, the first thing we do is we take, I tend to think of it like, where does these two matrices intersect when they multiply? So you take the first row and then the first column, basically this column here, and then you will multiply this, and that is going to have the position of the first row and the first column in the output matrix, so basically this. So we take 2 times 0.2, 3 times 0.6, 7 times 0.7, and 1 times 0.1, and then you would sum them up, and that is going to be the position of the first row, first column, right? So first row, first column, so it's going to be here. And then you can take let's say you take the first row and the second column. So you would take the first row and the second column, so we would take 2 times 0.4 and 3 times 0.3, 7 times 0.2, and 1 times 0.3, and then you sum them up, and that is going to have the position of the first row, second column, so it's going to be here. So it's going to sum up the 3.4, right? And then now we want to grab this, so you're going to take the second row and the first column. So you're going to take 4 times 0.2, 2 times 0.6, 1 times 0.7, and 9 times 0.1, and then you're going to sum them up, and that is going to be equal to 3.6 from the second row, first column, right? And now we only have this left, so you would take from the second row and second columns, you would take 4 times 0.4, 2 times 0.3, 1 times 0.2, and 9 times 0.3, and then you sum them up, and that is going to be equal to 5.1. Right, so I suggest you pause the video right now and do this by yourself, maybe on a piece of paper. It might help you, so you see the mechanics behind this. And also take a moment to wonder, like, the reason it seems so complicated to do it this way, but the reason why we do it this way is because this maps really well to how the data is put together. So now what we can do basically is we can just read in the whole data set as a matrix like this, and you can also read in all the weights as a matrix, and now what you only have to do is multiply them together, and that is going to yield this different output. So like, what does this matrix actually mean that we get here, this 2 by 2 matrix? So what this means basically is, like, for the first row here, when you apply the weights from the first column here, you're going to get this value. If you apply with the same data some other set of weights from this second column, you will get this weight right here. And so it's really intuitive once you do this, and the same thing goes for the second row here. So with the second row, when we apply the first column weights, you're going to get 3.6. So maybe we want to test out some other set of weights here from the second column, and then yeah, you get this value, right? So it's really easy once you're done with the multiplications. And in practice, you would of course never do this by hand. You would use something like NumPy in order to do it, and that's going to help you out a lot. And if you're going to do it in NumPy, this is how you would do it. You create M1 the same way as we did before. So you create this two-dimensional matrix here. You would wrap them in inner braces like this, and then some outer braces. And you would do the same thing for the other one. And then you would do the matrix multiplication. And make sure you have them in the right order, because otherwise you're going to get some other value. All right, so this is basically what we're after. We're after this mechanics. And I suggest you try this out on a piece of paper sometime, because it really helps you to grasp the context and see how it mechanically is done. And unfortunately, I think that's the way to go. You have to brute force this and see the mechanics in order to actually understand this. Alright, so I hope you guys liked it, and don't forget to subscribe if you haven't already, and leave any comments if anything is unclear, and I will see you in the next video. See you, bye bye.